Right now, as you sit still watching this, you are moving faster than a jet fighter. If you live near the equator, the Earth beneath your feet is spinning at over 1,000 miles per hour. At the same time, the planet itself is racing around the Sun at nearly 67,000 miles per hour. And beyond that, our entire solar system is being dragged through the Milky Way at roughly 500,000 miles per hour. You feel none of it. No wind rushing past your face. No pressure pinning you to your chair. No sense of motion at all. You feel exactly as still as you would standing in an empty parking lot. And that should strike you as strange, because at those speeds, almost anything else would tear itself apart or fling you off into space. So why don't you feel the Earth spinning? And more importantly, what would actually happen if you suddenly could? Most people assume the answer is simple. The Earth is just too big for a human body to notice, or the motion is too smooth to register. Both of those explanations sound reasonable, but they are incomplete, because the real answer is not about size at all. It is about the strange rules that govern motion itself, rules that Isaac Newton uncovered, and that your own inner ear still cannot fully process, even today. In the early 1600s, the astronomer Galileo Galilei was trying to defend a dangerous idea. Nicolaus Copernicus had proposed decades earlier that the Earth revolved around the Sun, not the other way around. Almost nobody believed him. It seemed obvious to everyone alive at the time that the ground was still. After all, if the Earth were really spinning at hundreds of miles per hour, wouldn't a ball thrown straight up land somewhere completely different when it came back down? Wouldn't birds be swept off course? Wouldn't people feel some kind of constant wind? Galileo answered this with a thought experiment. Imagine standing inside the cabin of a ship sailing smoothly across calm water. If you drop a ball, jump in place, or toss something to a friend, everything behaves exactly as it would on dry land. You cannot feel the ship's steady motion from inside it, because you, the ball, and the air around you are all moving together at the same speed. Only if the ship suddenly speeds up, slows down, or turns do you feel anything at all. The Earth is that ship. You are not standing still while the planet spins beneath you. You are spinning with it, along with the atmosphere, the oceans, and every object around you. There is no relative motion to detect, and your body has no way to sense a speed it is fully part of. This idea eventually became one of the foundations of physics. Newton later formalized it into his first law of motion. And centuries after that, Albert Einstein pushed it even further. Einstein realized that there is no experiment you can perform, sealed off from the outside world, that can tell you whether you are moving at a constant speed or standing perfectly still. Constant motion and stillness feel identical from the inside. Your senses were never built to detect speed. They were only ever built to detect change. That distinction matters because your inner ear, the organ responsible for your sense of balance, does not measure velocity at all. It measures acceleration. Tiny fluid-filled canals inside your ear shift only when your motion speeds up, slows down, or changes direction. Since the Earth's rotation is remarkably steady, your inner ear has nothing to register. As far as your body is concerned, a spinning planet and a motionless one send exactly the same signal. Nothing. But scientists eventually found proof that the spin was real, even if no human could feel it directly. In 1851, a French physicist named Léon Foucault set up a massive pendulum inside the Pantheon in Paris. The pendulum swung back and forth in a straight line, exactly as any pendulum should. Except over the course of the day, the direction of its swing appeared to slowly rotate. The pendulum itself had not changed course. The floor beneath it and the entire building around it had been slowly turning underneath it as the Earth rotated. For the first time, people could stand in a room and visually watch physical proof of the planet's spin, without needing a telescope or a mathematical proof. It became one of the most famous experiments in the history of science, and versions of Foucault's pendulum still swing in museums across the country today. Around the same period, scientists began noticing something even stranger. Objects moving across long distances on Earth, like ocean currents, wind systems, and artillery shells, did not travel in perfectly straight lines. They curved. In 1835, the mathematician Gaspard Gustave de Coriolis explained why. Because the Earth is a rotating sphere, different latitudes move at different speeds. The equator spins faster than regions closer to the poles. Anything moving freely across that surface gets subtly deflected, curving right in the northern hemisphere and left in the southern hemisphere. This became known as the Coriolis effect, and it is the reason hurricanes spiral the way they do, the reason long-range missiles require rotational corrections, and the reason massive ocean currents circulate in the patterns they do. The planet's spin was not just theoretical anymore, it was steering the weather. And yet, despite centuries of proof, something strange remains true. Your own body still does not believe it. So what would actually happen if it did? What would happen if your senses suddenly switched on and started registering the spin? Scientists who study spatial disorientation already have a partial answer, because pilots experience something close to it. High in the sky, without a visible horizon, a pilot's inner ear can begin sending false signals about the aircraft's orientation. Aviators call one version of this the leans, a sensation where the body insists the plane is banking sharply, even though it is flying straight and level. Pilots have flown fully functioning aircraft into the ground because their inner ear overpowered their own instruments. That is what happens when your vestibular system misreads motion it was never built to interpret correctly, even for a few confused seconds. Now imagine that system switched on permanently, tuned to a spin of 1,000 miles per hour and an orbit of 67,000 miles per hour. Running every moment of your life, you would likely never feel steady again. Every step would carry an unshakable sense of sliding sideways, because the ground truly would be sliding sideways, just too smoothly for your senses to have ever noticed it before. Standing near the equator, where rotational speed is highest, might feel like standing on a silent carousel that never stops. Traveling toward the poles, where that same rotation covers less distance per hour, might feel like slowly braking, even while walking at an ordinary pace. And because Earth's orbit around the Sun is not a perfect circle but a slight ellipse, the planet genuinely speeds up and slows down over the course of a year, moving faster in January and slower in July. If you could feel that too, you would notice something like a faint seasonal current tugging you forward each winter and easing off each summer. In short, if you could truly feel the Earth spinning, you would likely spend your entire life in a state of low-grade vertigo, unable to fully trust the ground beneath your own feet. The stillness you feel right now is not a lack of motion. It is a kind of protection, and quite possibly the only thing keeping you upright. Even now, most people go through their entire lives with an intuitive, almost stubborn sense that the ground beneath them is fixed and still. It is one of the deepest assumptions the human brain holds, built in long before anyone understood orbital mechanics. For most of human history, that assumption made perfect sense. Early astronomers and philosophers looked at the sky, watched the sun and stars appear to move around them, and concluded that the Earth must be the unmoving center of everything. Entire religious and scientific systems were built around that belief. When Galileo publicly supported the idea that the Earth moved instead, the Catholic Church placed him under house arrest for the rest of his life. Questioning the stillness of the ground was not just unusual. For a long time it was considered heresy. Today, nobody is punished for believing the Earth spins, but your senses still quietly resist it. You can hear every explanation in this video, fully understand the physics, and still walk outside afterward feeling completely still, because feeling still is not a belief. It is a built-in limitation of human perception, which raises an unsettling question. If your body cannot detect a 1,000 mile per hour spin, or a 67,000 mile per hour orbit, or a 500,000 mile per hour journey through the galaxy, what else might be happening around you right now that you are simply not equipped to feel? Modern GPS satellites have to correct for Earth's rotation and orbital speed constantly, using calculations based on both Newton's laws and Einstein's relativity, just to stay accurate to within a few feet. Air traffic controllers and long-range naval systems build the Coriolis effect into their calculations every single day. The evidence surrounds us, encoded into weather patterns, flight paths, and the quiet mathematics running behind your phone's map app. The planet has never stopped moving. It never once slowed down to let you notice. Maybe that is the real lesson hiding inside this question. Stillness, the most basic feeling you have, the sense that grounds nearly every other experience of reality, might be nothing more than an illusion created by consistency. You are not standing on solid, motionless ground. You are riding a spinning rock, hurtling around a star, being pulled through a galaxy at incomprehensible speed, and your entire nervous system, the only tool you have for understanding the world, was never built to notice any of it. You have spent your entire life in motion. You have simply never been able to feel it. And now you know that if you ever could, you might spend the rest of your life wishing you couldn't.